This is the OCR GCSE 9-1 Maths Paper 4 covering the higher tier, and it's from the November 2019 series, and it's a calculator paper. Question number 1. Carol makes birthday cards. Each card takes the same amount of time to make. She makes 3 cards in 48 minutes. She has an order for 80 cards. Can she complete this order in 3 days if she works 8 hours each day? Well, first of all, you'll notice here we've got minutes and here we've got hours. It makes sense for us to make sure we have consistent units. To go from minutes to hours, we would have to divide by 60, and to go from hours to minutes, we would have to multiply by 60, and therefore 8 hours, that's equal to 8 times by 60, which is 480. So she works 480 minutes each day. Now if she takes 48 minutes to make 3 cards, what we can do with this information is find out how many cards she can make in 1 day. So, in 1 day, what we have here is 3 cards in 48 minutes, and therefore we have 1 card in 48 divided by 3, which is 16 minutes. So in 1 day, she can make 480 divided by 16. So 480 divided by 16, she can make 30 cards in 1 day. Now, she needs to make a total of 80 cards. So therefore, we can find out how long it will take to make 80 cards. For 80 cards, it will take 80 divided by 30, which is 2.6, etc. days. And because this is less than the 3 days as suggested, what we can therefore conclude is she can indeed complete the order. Question number 2, we have to use the formula f equals s over the square root of tm to find the value of f when s is equal to 5.8 times 10 to the 6, t equals 4.1 times 10 to the 8, and m equals 3.7 times 10 to the minus 2. We have to give our answer in standard form, correct to 2 significant figures. Well, you'd recall for standard form, that's when a number is of the form a times by 10 to the power of n, where a is in between 1 and 10. Now, what we can do is find out what f is. F is equal to, well, we've got s, which is 5.8 times by 10 to the power of 6, divided by the square root of t, which is 4.1 times by 10 to the power of 8, multiplied by m, which is 3.7 times 10 to the minus 2. So if we work out what f is, what we can do is use our calculator. We have 5.8 times 10 to the power of 6 divided by the square root of 4.1 times 10 to the power of 8 multiplied by 3.7 times 10 to the minus 2. And it turns out here we would get 1437.789, etc. And if we write this in standard form, what we need to do is move this decimal place 1, 2, 3 places to the left. So we will end up with 1.4377, etc. times 10 to the power of 3. And therefore, to two significant figures, f is equal to 1.5 times by 10 to the power of 3. So this is given to two significant figures. Question number 3. At a railway station, trains are either eastbound or westbound. An eastbound train leaves the station every 25 minutes. A westbound train leaves the station every 45 minutes. An eastbound train and a westbound train both leave at 8 AM. When is the next time that the two trains will leave the station together? Well, here what we need to do is find the lowest common multiple of 25 and 45. Well, what we'll do is we'll list the multiples of 25 and 45, and from that we can find the lowest common multiple. So if we consider the eastbound, it leaves the station every 25 minutes, so we've got 25, 50, 75, 100, 125, 150, 175, 200. Then we have 225, 250, 275, and we could continue. And if we consider westbound, well, what we'd have here, if we list the multiples of 45, we've got 45, 90, then we've got 135, then we have 180, then we have 225, then we have 270, and we could continue, but what you'd notice over here is the lowest common multiple of both is 225. So therefore the lowest common multiple of 25 and 45 is equal to 225. So we've got 225 minutes that we need to add on to 8 AM. Well, what we can do as well is convert the minutes into hours and minutes. So to go from minutes to hours, we would have to divide by 60, and hours to minutes, we'd have to times by 60. So if we do 225 divided by 60, what we get is 15/4, which is 3 3/4. So here we've got 3 hours. Well, 1/4 of an hour is 15 minutes, so 3/4 is 75 minutes. Rather, 3/4 of an hour is 45 minutes. So what we now need to do is add on 3 hours 45 minutes, and therefore we'd have 11:45 AM as our answer. Question number 4. Bob makes dry concrete by mixing cement, sand and stone in the ratio 1:2:3 by weight. He buys the cement, sand and stone in bags as shown in this table. He packs the dry concrete into 30 kilogram bags. Bob buys just enough cement, sand and stone to make 50 bags of dry concrete. For part A, we have to show that Bob buys 500 kilograms of sand. Well, what we have is, for each bag, we've got 30 kilograms for dry concrete, and we need to make 50 bags, and therefore the total weight that's equal to 50, because we've got 50 bags, times by 30, so it turns out here we get 1500 kilograms for the total weight of all 50 bags. So this is for all 50 bags. Now, we need to show that he buys 500 kilograms of sand. Well, if we use our ratio, what you can see from our ratio is 1 plus 2 plus 3, that's 6. So we have 6 parts over here. And therefore, what we can now do is find out how much we'd have for each part. So, for each part we'd have 1500 divided by 6. So 1500 divided by 6, that's 250. So we've got 250 kilograms per part. And therefore, for sand, well, what you can see for sand, if we go back to our ratio, we've got 2 parts, and therefore for sand we've got 2 times by 250, which is 500. So we've got 500 kilograms for sand. And now for part B, Bob sells the 50 bags of dry concrete for a total of £396. You have to calculate his percentage profit. Well, if we pay attention to this table, we've got the weight for the different ingredients and the cost per bag. And what we can do over here is find out how many bags we need. But before we do that, we can find out how much of each ingredient he would need for 50 bags. Remember, this sand over here is for 50 bags of sand. So we need to multiply 250 by 1. That tells us how much cement we have. For cement, we have 250 times by, we'll just keep everything consistent. We've got 1 times by 250, which is 250. So we've got 250 kilograms for 50 bags. And if we consider the stone, we had 3 parts, so we've got 3 times by 250, which is 750 kilograms. And again, this is 450 bags. So what we can now do is find out how many bags of each we need. So for the number of bags, for cement, what we'd have is, if we consider cement, we've got here 25 kilograms for the bag. So we've got here 250 divided by 25, which is 10. So we require 10 bags of cement. And therefore the cost here, we would have 10 multiplied by, well, if we go back to the cost for this, we've got 10 times by 550, which is £55, 50 pence. And similarly for sand, we would have 500 divided by, so we've got the 500 from here, divided by 20, which is 25. So we've got 25 bags of sand, and therefore the cost for this is equal to 25 multiplied by, if we go back to the table, £2. So here we've got £50, and therefore for the stone we'd have 750 divided by the 15. So 700 divided by 15, that's 50. So we require 50 bags of stone. Therefore, the cost for this is equal to 50 multiplied by 390. So if we work this out, 50 times by 390, that's 195. So we have to pay £195 for the stone, and therefore for the total cost, this is equal to 55.50 plus 50 plus the 195. So therefore for the total cost, we've got 195 plus 95, which is 290. So therefore it costs us, rather here we've got 195 plus 95. Rather here we've got 105. So here we get 300 for the total cost. Okay, so for the percentage profit, we'd have over here, well, he sells for a total of 396. So we've got here 396 take away 300 divided by the 300, and then we times by 100. So we've got 396 take away this, and then we divide this by 396 rather. No, we don't. We divide this by 300, and then times by 100. It turns out here we get 32. So the percentage profit is 32%. Question number 5. We have to multiply out and simplify 4x plus y lots of x minus 3y. Well, 4x times by x, that's 4x squared. And then we have 4x times by minus 3y, so that will be minus 12xy. And then we've got y times by x, which is xy. And then we have y times by minus 3y, which is minus 3y squared. And therefore, if we simplify all this, we would have 4x squared. We've got minus 12xy plus xy, so that's minus 11xy. And then we've got minus 3y squared. So this is our answer. Question number 6. A bag of sweets contains only mints, sherbets and toffees. The ratio of the number of mints to sherbets is 2 to 3, so we've got we've got M to S equaling 2 to 3, and the ratio of S to T is equal to 7 to 5. And we have to find out what fraction of the sweets are sherbets. So before we do anything else, what we need to find is the ratio of M to S to T. Now the problem is, the S's aren't the same already. What we want these to say, well, if we think about the lowest common multiple of 7 and 3, that will be 21. So we want a 21 here, so the S's are the same. That's what we want. Now, to go from 3 to 21, we times by 7. So 2 times by 7, that's 14. So we've got 14 mint. And to go from the 7 to the 21, we times by 3. And therefore 5 times by 3, that's 15. So we've got 15 for T. And therefore, the fraction of the sweets which are sherbets, we would have here 21 out of 14 plus 21 plus 15, which is 21 over 50. So we have 21 over 50 as our fraction. Question number 7. 12 students take 2 tests and each test is out of 60, and the scatter diagram shows the results for 10 of the students. And the table here shows information for the other 2 students, and we have to plot these on a scatter diagram. Well, if we consider this student, we've got 36 and 44. So 36, 44, that goes over here. And then we've got 38, 41. So 38, 41, that goes over here. And then for part B, we have to describe the type of correlation in the scatter diagram. Well, as one quantity increases, the other increases, and therefore we have here a positive correlation. Now for part C, we have to draw a line of best fit. So if we draw a line of best fit, we want it to go through as many points as possible. So we want the same number of points roughly above the line as we have below the line. So we've got 1, 2, 3, 4, 5, 6, and here we've got 1, 2, 3, 4, 5, 6. So here roughly we've got our line of best fit. And then another student was absent for test 2. The student scored 40 marks on test 1. We have to use our line of best fit to estimate a result for this student on test 2. Well, if he got 40 on test 1, then what we'll do is draw a vertical line up from 40, as we have here, and draw a line across. You can see then that this student's mark is 40 on test 2. And now for part D, we have to work out the percentage of the 12 students whose result on test 1 is lower than their result on test 2. So those who have a lower result on test 1 than test 2, well, we have here 1, 2, 3, 4, 5, and 6. So there's 6 students who've got a test mark lower on test 1 than test 2, and therefore we'd have 6 over 12 times by 100. So we've got a half times by 100, which is 50%. So we've got 50%. Question number 8. The diagram shows the price paid by 2 groups of people visiting a fun fair, and for 5 adults and 4 children we've got a total of £78, and for 3 adults and 6 children we've got a total of £63. Assume each adult pays the same price and each child pays the same price. We have to find the price for an adult ticket and a price for a child ticket. Well, first of all, we've got 5 adults and 4 children equaling 78. And then we've got 3 adults plus 6 children equaling 63. We've got 2 unknowns with 2 equations. We'd have to solve these simultaneously. What we'd do is we'll multiply this equation by 5. Rather, we'll multiply this by 3 and we'll multiply this by 5. And if we do that, we'd have 15a plus 12c. Now, 3 times 78, that's 234. And then we've got 15a plus 30c equals, well, 63 times 5, that's 315. So now if we subtract these equations, 30 take away 12, that's 18. So we've got 18c equals 315 take away 234, which is 81. So therefore, c is equal to £4. £50. So a child ticket costs £4.50. And if a child ticket costs £4.50, we can use this to find out what an adult ticket is. So we have 3 times buy an adult ticket plus 6 lots of £4.50 equals 63. So we have 3a plus, well, if I multiply this by 6, we end up with 27. So we've got 3a plus 27 equals 63. So 63 take away 27, that's 36. So we've got 3a equals 36, and therefore a is equal to 12. So an adult ticket costs £12 and a child ticket costs £4.50. Question number 9. Here is a function a. So we input, we take away 4, we times 3, we get an output. For part A, a number k is input into function a. The output is also k. We have to find the value of k. Well, we'd have here k minus 4 multiplied by 3. This is equal to k. So we've got 3k minus 4 equals k, rather 3k minus 12 equals k. 2k is equal to 12, and therefore k is equal to 6. So we've got k equals 6, and now for part B, the output of function a is y. We have to write down an algebraic expression in terms of y for the input of a. Well, what we have here, if we have an output of y, we inputted something. So here, if we've got an output of y, the thing we did before outputting was we times by 3. So if our output was y, then we'd have to divide by 3. And then if we subtracted 4 before that, then the opposite of that is plus 4. So here is our algebraic expression. We have y over 3 plus 4. And now for part C, the diagram shows a composite function with an input n and an output of 96. And what we have to do is find the value of n. Well, if we consider what function a was, that was input minus 4 times 3. So if we input n and we put that into function a, we get n minus 4 times 3. So here we'd have n minus 4 multiplied by 3. And then what we will do is input this into function a again. So what we'd have here is 3 lots of n minus 4 minus 4, and then we get 96. So we get 3 lots of n minus 4 minus 4 equals 96. So we've got 3 lots of 3n, well, we've got minus 12 minus another 4, so that's minus 16, and this is equal to 96. 96 divided by 3, that's 32. So we've got 3n minus 16 equals 32. So if I add 16 to both sides, we have 3n equals 48, and therefore n is equal to 16. Question number 10. The value of a house h pounds is given by the formula h equals 165,000 times by 1.03 to the power of t, where t is the number of years after the 1st of January 2010. We have to write down the value of the house on the 1st of January 2010. Well, quite simply, this is when t is equal to 0. And when t equals 0, we have h equals 165,000 times by 1.03 to the power of 0. So we've got 165,000 times by 1, which is just 165,000. Now for part B, we have to write down the annual percentage increase in the value of the house. Well, can you see here that we've got a multiplier of 1.03. And this will correspond to a 3% increase. So we've got 3% as our increase. And then for part C, we have to show that the value of the house is over £200,000 on the 1st of January 2017. Well, from 2010 to 2017, that is 7 years. And therefore what we have here is the value H equaling 165,000 times by 1.03 to the power of 7, which is 202,929.19 to 2 decimal places. And what you can see here is this is indeed greater than the 200,000, and therefore that's exactly what we wanted to show. Question number 11 for part A. Are these two triangles definitely congruent? Give a reason for your answer. Well, whilst this angle corresponds with this angle, and whilst this angle corresponds with this angle, and whilst this angle corresponds with this angle, what you can see here is that we don't know anything about the lengths. So we don't know anything about the scale factor. So therefore, what we'd say here is no, because the lengths are unknown. And now for part B, we have to prove that these triangles are congruent. Well, what you can first of all see here is this angle is the same as this angle. So you can see that HGI equals KJL, which is 36 degrees. You can also see that this is equal to this, so HG equals KJ, which equals 9 centimeters, and you can also see this equals this, so GI equals JL, which is 7 centimeters, and therefore what we can conclude over here is we have side, angle, side, and therefore we can conclude that they are congruent. Question number 12. The cumulative frequency graph summarizes the annual salary P pounds of the 60 workers in a factory. And for part A, we have to use the graph to estimate the median annual salary. Well, if we've got 60 workers, dividing this by 2, that gets us 30. So if we look for the 30th value, that is over here. And if we go down and read the corresponding salary, you will find this to be 24. And now for part B, we have to complete this cumulative frequency table. So when we have over here a cumulative frequency of 10, or rather up to 10, well, certainly for here we'll get 60. So let's just write that down. So let's think about how we can do this. We'll work backwards. So what we're saying is up to, when we've got a annual salary of up to 10, that corresponds here to 14. For 20, we have here 26. For up to 30, we've got 36, and up to 50 we get 50. So here is our cumulative frequency table. And now for part C, we have to use the information in the cumulative frequency table to calculate an estimate of the mean annual salary. Well, if we consider these as an interval, what we're saying over here is we're going from 0 up to 10. And here we're going from 10 to 20. Here we're going from 20 to 30. Here we're going from 30 to 50. And here we're going from 50 to 80. We now need to find the midpoints. We have 5, 15, 25, 40, and then the midpoint over here is 65. So now we need to do the midpoint multiplied by the frequency. So if we work these relevant values out, what we have here is 5 times 14, which is 70, 15 times 26, which is 390, rather before here what we need is the frequencies. So for our frequencies, what we can do is use our cumulative frequency to help us. So if we find out the frequencies, well, we're starting off at 14. 14 plus something is 26, so that's 12. And then 26 plus something is 36, so here we've got 10. And then we've got 36 plus something gives us 50, so here we'd have 14. And then 50 plus something gives us 60, so here we'd have 10. And now if we work out frequency times midpoint, what we have here is 14 times by 5, which is 70. Then we've got 12 times by 15, which is 180. Then we've got 36 times 25, which is 900. Let's check this out rather. Sorry, we've got here 10 times by 25, which is 250. 14 times by 40, that's 560. And then we have 10 times by 65, which is 650. So if we add all this together, what we'd have then is 70 plus 180 plus 250 plus 560 plus 650. That gets us a value of 1710. So if we add all this together, what we'd get is a value of 1710. And if we add up all the frequencies, we get a value of 60. So how does this help us? Well, what we can now do is use the fact that the mean is equal to the sum of the frequency times the midpoints over the sum of the frequencies. So we've got 1710 divided by 60. So if I divide this by 60, we get 28.5. So here we end up with 28.5. And now for part D, we have to explain why your estimate to the median is more reliable than your estimate for the median. So for the mean, the figures used are approximates. Question number 13. For part A, a transport lorry consists of a cab and a trailer. The trailer has a volume of 90 meters cubed. Alfie makes a model of this lorry using a scale of 1 to 72. We have to work out the volume of the trailer in Alfie's model, giving an answer in centimeters cubed. Well, if we consider this scale, what we have is a length scale factor of 72, and therefore for the volume scale factor, that will equal 72 cubed. So therefore the volume of his trailer in the model, well, in real life, we've got 90 meters cubed, so we have to divide by the volume scale factor, so we'd have to divide by 72 cubed to find the volume. And if we do that, we've got 90 divided by 72 cubed, which is this value over here. We get 2.411, etc. meters cubed. Well, we want our answer in centimeters cubed. To go from meters to centimeters, here would have to times by 100, and to go from centimeters to meters, we'd have to divide by 100, and therefore to go from meters cubed to centimeters cubed, we'd have to times by 100 cubed. Centimeters cubed to meters cubed, we'd have to divide by 100 cubed. So if I multiply this by 100 cubed, it turns out here we get 241.126, etc. centimeters cubed. So we would have 241.1 centimeters cubed given to one decimal place. Now for part B of the question, Alfie paints his model lorry. He has 8 colours available. He decides to paint the cab in one colour and the trailer in a different colour. He then wants to paint his name on the trailer. There must be a different colour to the trailer. In how many different ways can Alfie paint his model lorry? Well, what we have over here is 8. So this over here corresponds to the 8 colours available. We've got 8 colours available. And then we multiply this by 7 because he wants the trailer to be a different colour. Now what we'd have to do over here then is multiply by 7 again, because we can't have the same colour used that we used for the cab. So we'd have another 7 options available. So this is the fact that we can't use the same colour for the trailer. So we can't use the same colour we had here, so we've got another 7 options available, given we don't use this colour. So if we work all of this out, 8 times by 7 times by 7, that's 392. So we've got 392 different options. Question number 15. The diagram shows a circle with centre at the origin and a tangent at the point -12, 16, and the tangent crosses the y-axis at the point with coordinates 0, p, and we have to find the value of p. Well, to do this, what we need to do is find out the equation of the tangent before we do anything else. And to do that, what we need is the gradient. We need the gradient of the tangent, and for that we can find out the gradient of the radius. So the gradient of the radius, we've got the change in y, which is 16, over the change in x, which is -12. So 16 divided by -12, that's -4/3. So we've got -4/3 for the gradient of the radius, and recognizing that the radius and the tangent are perpendicular to each other, we can therefore conclude that the gradient of the tangent, this is equal to the negative reciprocal of -4/3, which is 3/4. So now that we've got the gradient of the tangent, and we've got the point where the tangent crosses through P, what we can now do is find out the equation of the tangent. So for the equation of the tangent, we would have here, well, we've got y equals mx plus c, so we've got here y, which is, if we look back, which is equal to 16. This is equal to the gradient 3/4 lots of minus 12 plus c. So here, all we've just done is use y equals mx plus c. So we've got 16 equals, well here we've got 1/4 of minus 12, which is minus 3, timesing that by 3 we get minus 9. So therefore c is equal to 25. And therefore we've got y equals 3/4 x plus 25. Now c over here would represent the y-intercept, and this is basically when x is 0. And if we compare over here, you can see x is 0 here. So therefore, p is equal to 25. Question number 15. For part A, we have to calculate the length of df in this triangle. Well, we've got here two sides and an angle in between those. We're calculating the side opposite to the angle, and therefore we'd have to use the cosine rule. So we have df squared equals 12 squared plus 10 squared, and then we've got minus 2 times by 12 times by 10 times by the cosine of 30. So what we can do is find out what df all squared is. So we've got 12 squared plus 10 squared minus 2 times by 10 times by 12 times by the cosine of 30. So here we get 36.15. And therefore for df we'd have the square root of this, which is 6.01, etc. So therefore we've got 6.01 given to three significant figures. And now for part B, we have to calculate the angle ACB, which is this angle here in this triangle. Well, here we've got if we think about what we've got a angle and a length opposite, and here we've got a length, but we've got an angle here adjacent. So what we'll do is we'll find out this angle y first of all, using the sine rule. So we've got here the sine of y over the 12.4 equaling the sine of 63 over 12.8. So therefore, sine of y, that's equal to 12.4 times by the sine of 63 divided by 12.8. And if we work this out, we have 12.4 times by the sine of 63 divided by 12.8, which is 0.863, etc. And therefore we can find out what y is. Y is equal to the inverse sine of this, which is 59.67. And therefore to find out what x is, we've got 180 because we've got sum of the angles in a triangle. Take away the 63 which was given, take away this 59.63, rather this 67, etc. So if we work this out, 180 take away this, take away 63, you'd find that to be 57.32. And therefore we've got 57.32 degrees to 1 decimal place. Question number 16, we have to show that x plus 9 over x squared minus 1 plus 4 over x plus 1 can be written in the form a over x minus 1, where a is an integer. Well, over here, we can rewrite the x squared minus 1 as a difference of two squares. We've got x plus 1, lots of x minus 1, and on the top we've got an x plus 9. And then we're adding on 4 over x plus 1. Well, what we'll do is we'll get the denominators the same. And if we get the denominators the same, what we want over here is an x minus 1. So here we'd also have an x minus 1. It's as though the bits in red cancel out, leaving us with the 4 over x plus 1. So now that we've got this common denominator, what we can now do is rewrite everything. What we'd have on the bottom is x plus 1 lots of x minus 1, and on the top we've got x plus 9 plus 4 lots of x minus 1. So if we tidy this up, we'd have x plus 9 plus 4x minus 1 over x, rather here we've got a 4x minus 4. So here we've got an x plus 1 lots of an x minus 1. So if we attempt to tidy this up even further, what we'd have on the top is x plus 4x, that's 5x. So we've got 5x plus 5 on the top, and on the bottom we've got x plus 1 lots of x minus 1. And therefore, we'd have 5 lots of x plus 1 lots of x plus 1 lots of x minus 1, which we can cancel the x plus 1's, leaving us with, over here, 5 over x minus 1. So what we will end up with is, if we pay attention to the required form, you can see then a is equal to 5. Question number 17, we have to sketch the graph of y equals 3 to the x. Give the value of the y-intercept. Well, when x is 0, y is equal to 3 to the power of 0, which is 1. So it crosses the y-axis at 1, and it's an exponential graph, so it looks something like this. So here we've got y equals 3 to the power of x, and it crosses the point 1, as we see here. Question number 18. The diagram shows a right-angled triangular prism ABCDEF, and the length AD is 11 centimeters, CD is 10, and CF is 6. We have to calculate the volume. Well, to work out the volume, what we'd have over here is half of a cuboid. And let's just demonstrate how that's the case. I'll draw a vertical line up from here, and then if we just show these lines over here, what you can hopefully see is how we have half of a cuboid. So therefore, for the volume, we'd have 1/2 times by 11 times by 10 times by 6. So if we work this out, 1/2 times by 11 times by 10 times by 6, that's 330. So we have 330 centimeters cubed. So hopefully that makes sense. And now for part B, we have to use trigonometry to show that the angle FDC is 31 degrees. So FDC, that's this angle here. So we've got the opposite 6, we've got the adjacent 10, so we've got the tangent of 6 over 10 equaling tan x. So therefore x is equal to the inverse tangent of 6 over 10, which is 30.96, which is approximately 31 degrees. And now for part C, we have to calculate the exact length of AF. So AF is this one over here. So we need to calculate that somehow. Well, what we can do to calculate the length of AF is use Pythagoras. So if we split this up, you can see here, we join everything up like so. We've got a right-angled triangle. So let's just show that. We've got here a right-angled triangle, and what we need to calculate the exact length of AF is this length over here. Well, actually what we can do to calculate this over here is just simply use 3D Pythagoras. What we'd have then is AF equaling 10 squared plus 11 squared plus 6 squared, all square rooted. So if we calculate this, 10 squared plus 6 squared plus 11 squared, square rooted, that's square root 257. So here we've got square root of 257. Question number 19. The graph shows the distance travelled by a particle over 8 seconds, so that's what we see here, and we have to estimate the speed of the particle at 5 seconds. Well, we've got a distance time graph, so what we need to do is draw a tangent at 5 seconds. So if we draw a tangent at 5 seconds, we would have something looking like this, and what we need to do is calculate the gradient of this. Now the gradient, that's the change in y over the change in x. So for the change in y, we can use this as our change in y, and we can use this as our change in x. So change in y, that's equal to, well, we're going from 0 to, well, we've got 4.4 over here. And the change in x, we're going from 2.7 to 6. So 6 take away 2.7, that's 3.3. So here we'd have change in x equaling 3.3. So therefore, what we'd have then is the estimate of the speed, that's equal to 4.4 meters over change in x. So we divide by 3.3 meters. 4.4 divided by 3.3, that's 4 over 3, which is 1.3, etc. Rather, here we've got seconds. So here we've got 1.33 meters per second. So we've got 1.33 meters per second. So that's the end of the paper. Don't forget to like, share and subscribe, and any questions, do feel free to comment them in the comment section below, and hopefully I'll see you on the next video.